Hi, in this lecture video, I'll be doing a comparisons between the two topics, kinetics and thermodynamic of a reaction. So first, let's discuss kinetic. Whenever we hear of kinetic, we should be thinking about the rate of reaction. How fast or how slow can a reaction happen? And this is basically dependent on the activation energy of the reaction. So given this following potential energy diagram, how fast or slow or the kinetic of the reaction is then affected by this activation energy. And again, this is the energy difference between the reactant and the transient state. The higher the activation energy, or the higher this gap would be, then the more the activation energy would be and the slower the reaction rate would be. So lower activation energy corresponds to the faster of the reaction. And again, kinetic referring to the rate. Whereas if we were to be thinking of the thermodynamic aspect of reaction, then that's when we are thinking of about the stability of reactant and products. So reactants and product can have different stability on them, and at equilibrium, one is in favor over the other, depending on whichever one is more stable. So again, think of stability at equilibrium whenever we think of thermodynamics. For an example over here, so here in this case right here would be the reactant and the product. And in this case right here, the products are more stable compared to the reactant based on this potential energy diagram. And here in this case right here, because the product is more stable, so in this case, the reaction, once they have reached equilibrium already, it will be favoring the product side. So again, we see that when the delta G is negative, it will be favoring the product side. And because the product will be more stable than the reactant. But then that is what we should be thinking about whenever we hear of thermodynamic. So again, think of stability, and the reaction will proceed in the direction that favor the more stable substance. And a lot of time, that will then be the product. Now notice that these two diagrams right here are exactly the same thing, but only our emphasis will be different. So here, when we think of kinetic, we are thinking about activation energy. Versus when we think of thermodynamic, we are thinking about energy difference between the reactant and the product. So the two topics tie together in different way. And now, kinetic products. Kinetic products are basically a product that form in a reaction where multiple products are possible. So many reactions can have various types of product depending on the pathway that occur. So in a reaction where different paths can occur, which one form first? Whichever products that can form first, we then refer to that product as the kinetic product. And again, the kinetic product is the product that can form first in a reaction where multiple products are possible. Versus the thermodynamic products are basically the product that are more stable, that get produced in a reaction where multiple products are possible. For an example, let's say here, given the reactions 1. In this case right here, A and B, this reactant right here can undergo two different pathways to give rise to an E and F product or C or D product. So these are two pathways that are possible. So here in this case right here, the line in blue represent a step that have the smaller activation energy. And therefore we can see that, and that will then lead to the product C and D. So in this case right here, the pathway leading to D have a lower or smaller activation energy. So in this case right here, C and D will then be the kinetic product. Because this is the product right here that get produced first due to its pathway having a smaller activation energy. And now here in E and F right here, so E and F in this case right here, this is not be even the kinetic product or the thermodynamic product. So this is none of it. C and D will be both the kinetic product and also the thermodynamic product as well. Because C and D are more stable than E and F. So in this case right here, C and D will be said to be the kinetic product of this reaction, and also the thermodynamic product of this reaction as well, because it has small activation energy and it's more stable than E and F. And if we were to perform this reaction right here and we want to favor this product, then we need to do this reaction at a colder temperature, or keep it cold. And the reason why that is the case is because if we were to heat up, add in energy to heat this up, then now the reaction can go over both of this pathway right here. So it can do the blue pathway or also the red pathway, because there's too much heat energy being given. So in this case, both C and D and E and F can form. But if we were to keep this cold and only give the reaction this much energy right here to climb this hill, but not the other hill, then in that case, we'll be able to favor the product C and D. So we can favor and make some of this EF right here. When the reaction is hot, we'll be able to produce both a mixture of between all of these 4 different products right here. But if we were to keep this cold, we'll be able to favor the majority being the C and the D product. And again, the C and D product can be referred to as both the kinetic and the thermodynamic product. Versus here is reaction number 2. And in this case right here, again, there are 2 pathways. A and B can become E and F or C and D, depending on which path that they are taken. So here in this case right here, we will then see that C and D will then be the thermodynamic product and not E and F, because C and D is more stable due to having lower potential energy. So C and D, this will be the thermodynamic product, because this product right here are more stable than E and F. Now, but E and F here in this case right here, this would then be the kinetic product. So in this case right here, we can see that it's different than the previous example where the kinetic and the thermodynamic products are different products. So why are E and F the kinetic product? The answer is because the pathway leading to the formation of E and F have a smaller activation energy. So therefore it can happen faster. And therefore this then becomes the kinetic product. So if we were to want to favor the formations of the kinetic product here in this case right here, if we want to favor E and F, we should keep this reaction cold or do it at lower temperature. And the reason why is because if we are to provide only little external energy, then the reaction will only have enough activation energy to climb this hill right here, and therefore forming E and F. But if we were to now heat this up and do this reaction right here while it's very, very hot, then when it's hot, then now assuming the reaction will also have enough energy to climb this hill as well, to reach the transient state for this pathway in blue, and that would then favor the formation of the C and D product. So in this case, the kinetic and the thermodynamic products are different products. So let's go back and put all of this in. What are the thermodynamic products for reaction 1? So in the case of reaction 1, the thermodynamic product here will be the more stable. Again, we should be thinking of the more stable product, and this would then be C and D. And then reaction 2, the thermodynamic product would still be C and D as well, because C and D are more stable. And as for the kinetic products in the reaction 1, so this, again, kinetic refer to the reaction that are produced due to the pathway that have lower activation energy. So in this case, this is also C and D as well. Versus in the reaction number 2, the kinetic products would then be the E and F products.